Hi, everybody, and welcome to Echo Live. Today we are doing a music making episode here. My name is Anna, and I'm coming to you from the Michigan Science Center's Echo Distance Learning Program. Welcome to all of our friends joining us in Zoom, on Facebook, and on our YouTube live page. If you haven't done so already, as always, go ahead and introduce yourself in the chat feature of whichever program you are tuning in from. We are so excited to see so many familiar faces tuning in. Hi, Evan from Texas. Hi, Carter from Michigan. Hi, everybody. Thanks so much for joining. We have a very exciting program planned today because we're talking about music making, and all of these experiments or activities are things that you can try at home. I want you to be music makers. So I'm going to teach you how to make a few different musical instruments, and we're going to talk about the science behind musical instruments, how they actually make music, and what the science is behind them. So thanks everyone so much for typing in the chat. You can also tell me in the chat if you are someone who already plays a musical instrument. Tell me what that is. I know that when I was in 4th grade, I started playing the violin. I didn't stick with it for very long, unfortunately, but I know that sometimes in elementary school, some people have opportunities to learn musical instruments. Maybe if it's not at school, maybe you are learning a musical instrument at home or in your free time. Maybe with some of your time you've spent at home, maybe you've been learning how to play an instrument through virtual music lessons. That would be an amazing use of your time while you've been at home and while we continue to be learning new things from home going forward. Now, we're going to talk about sound here on this episode today. And we've talked about sound on Echo Live in the past. We are familiar with the fact that sound is a vibration. Now, when sound becomes beautiful or harmonious, right, we start to call it music. So all musical instruments do is they turn those vibrations into sound energy in a way that is pleasant to our ears. Now, let's talk about those properties of sound that we've discussed on Echo Live in the past. The two most important properties of sound waves are frequency and amplitude. You might remember those from one of our past episodes of Echo Live where we've discussed frequency and amplitude, but let's go back over those very quickly. First, let's discuss frequency, because in sound or in physics, we say that frequency determines the pitch of a sound that we hear. The frequency has to do with wavelength, which is denoted by the distance between two peaks on a sound wave. So we've got two peaks up here, which are measured with this arrow here. That one is noting a short wavelength, which we would call a high frequency sound. And on the bottom, this arrow is much longer. So we have a longer wavelength, which we call a low frequency sound. We call it frequency, right? Because in the same amount of distance, even though that we're traveling the same amount of distance, there are far more of these high frequency sound waves on top than these low frequency sound waves on the bottom. So same amount of space, same distance, and same amplitude, which we'll get to in just a minute, but different wavelengths, which give us high or low pitch sounds. We can practice this at home, and there's a really easy way to practice this. You actually don't need a musical instrument to do this demonstration at all. Instead, we're just going to practice using our vocal cords to create a high and a low pitched noise. We're going to repeat the same phrase 2 times, but once we'll say it with a high pitched voice, and once we'll say it with a low-pitched voice. So hopefully you have pretty good range. If you need to warm up your vocal cords just a little bit, go ahead and give me a me, 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 me. Now, I can't hear you at home, but hopefully I'm not the only one playing along in this game. But this first time, I want you to repeat after me in your most high-pitched voice. Everyone say, "We love science." Ready? We love science. When we make a high-pitched noise, right, we have lots of those high frequency or short wavelength sound waves being created. Your vocal cords are vibrating very, very quickly to create those high-pitched sounds. Now we're going to say that same phrase again, but in our most low-pitched voice. Ready? Repeat after me. We love science. We love science. When you make a low-pitched noise or voice, your vocal cords are vibrating much more slowly. So, right, we said that frequency relates to pitch, how high or how low a sound is. An easy thing that you can create at home to explore how frequency is related to pitch and these different wavelength sounds is by creating a water xylophone, which I've actually set up here using these 6 glass beakers. This one almost looks invisible because it's not very full of water, but that's okay. In each of my Erlenmeyer flasks, which is the name for this kind of pointy shaped beaker, in each of my Erlenmeyer flasks, I've filled them with different amounts of water. So starting over here with the red beaker, we've got a pretty high water level inside this glass. As we move down the line, there is less and less and less and less water inside our beakers here. So tell me, if you had to guess which one is going to make the highest pitch sound, remember high frequency, high pitch, is it the red beaker? Is it the yellow beaker? Or is it the purple beaker? Go ahead and tell me what you think. Which beaker or flask of water do you think is going to create the highest pitch sound? The way we're going to create the sound is by creating vibrations, right? So I'll be tapping our various flasks with this wooden spoon. If you're going to create this water xylophone at home, I highly recommend using glassware because glass vibrates very, very easily. But you want to be very careful. So using something like a wooden spoon, it's easy to be nice and gentle on your glass. Make sure you're not breaking anything as you just tap gently on each of your glasses. So you don't have to have beakers like mine. You can use any sort of glassware. It's important that they are similar or even better, identical. So I have 5 identical flasks up here on the table, but you can use 5 glasses from your kitchen and you can recreate this at home. So go ahead, tell me what you think. Lots of guesses starting to come in. Some friends guessing red, some friends guessing purple, no one guessing yellow. So we're pretty confident that the level of the water is going to correspond to the pitch somehow. That might mean that it's either the highest amount of water creates the highest pitch or the lowest amount of water creates the highest pitch. But we're a little bit mixed on our results. So let's go ahead. I'm going to turn on my second microphone here. Make sure we get a good up close listen at how our different flasks sound. So listen carefully and tell me which one is higher pitched. Ready? Which one is higher? Now that we've actually tested our water xylophone here, which one creates the higher pitched sound? Is it red or is it purple? Give you a moment now that we've got some observations that we've made using our power of hearing. Is it red or purple? Awesome. It is the purple beaker. The beaker that has the lowest level of water creates the highest frequency sound. And that's all about vibrations, right? So no matter which of these instruments I tap on, they all make a different frequency or pitch, which means that they create a different musical note. If you are a musician, you might know that high and low pitch translates to different notes on a musical scale as well. And so this purple beaker vibrates the fastest. With the least amount of water, it doesn't have as much matter to move. So in our red beaker, right, there's a lot more water. So the water inside will actually slow down the frequency of that sound wave, giving us those very low frequency or long wavelength notes. Now, this water xylophone works like a real xylophone. You can actually use it to play a song, and I've been practicing, of course, before this episode. So tell me if you recognize this song. Tell me if you recognize it. Anybody? I know that they're not perfect. I've not quite perfected the tuning of my notes here, but it's a pretty familiar sound. Maybe if I hum it along with our song here, maybe you can tell me. If you recognize it, tell me in the chat. If you couldn't quite get it, let me hum along and let's see if we can get it this time. It is my rendition on the water xylophone of Mary Had a Little Lamb. Thank you. Oh my goodness, people actually got it. I am pretty proud. A musician I am not. I'll leave most of the music making to Raul, but this is the best I've got. Now, Mary Had a Little Lamb is an easy way for you to practice on your own water xylophone. And again, this is showing us how different frequency sounds translate to different pitches. But I have another instrument that relies on the same thing. We can also create a very easy at-home pan flute. So if you haven't heard of a pan flute, they're really, really interesting looking musical instruments. They look like a bunch of taped together straws or sticks, and you actually blow air across the top of them, which is exactly what we're going to do using some of these colorful drinking straws. So I've got some colorful drinking straws, some tape, and a pair of scissors. So what I've done before our episode started today is I took some of those drinking straws and I cut them at various lengths. So instead of using water to change the frequency of our sound waves, this time we're actually going to use the different lengths of my straws here. So now that I picked them up, I kind of messed up my order here, but all we need to do is rearrange them in order from longest to shortest. So based on what we learned with our water xylophone, which straws, the red or the pink, which one do you think is going to create the highest pitch sound? Highest pitch. So remember, fastest frequency, shortest wavelength, and that would give us the highest pitch noise. Is it our long red straws or is it our short pink straws? So while you tell me which one you think it is, all you need to do is once you've cut your straws into your staggered lengths, we're just going to take some of that tape and secure all of our straws together. So we'll just take a piece of our yellow duct tape here, cut off a good piece of it, and then I'm just going to lay it across the top of my straws. Make sure it's really stuck on there. And then flip over my straws and secure them all together just by wrapping the tape. Now you want to keep your straws nice and flat. So it's good to do this on a flat tabletop, just like I'm doing here. So again, we're just securing all of our straws together and we arrange them ahead of time from longest to shortest. So let's see what you guys think. Which of these straws is going to make the highest pitch sound? And we've got lots of people telling us pink, right? So we're really thinking about the medium that our sound needs to travel through before it gets to our ears, right? Even though I'm going to blow the same amount of air across the top of our straws here to create vibrations, they'll have different distances to travel before they exit our pan flute. So let's go ahead. I'm going to hold up my second microphone and we're going to go ahead and I'm going to play my pan flute and we'll start with the red. So I'll start with the red and move to the pink. So we'll see if you guys are right, if the pink one really does create those high-pitched noises. Ready? Starting at red. Going to pink. Now this one, it doesn't come across the microphone quite as well. So let me get everything situated and let's see if we can get it going. And I would say that I can hear it much better than you might be able to hear it at home, that the pink straws make a much higher pitch sound, right? That's because those vibrations come out of those shorter distance straws much more quickly. Since our red straw is longer, it again, just like the water, will slow down the frequency of our vibrations and make those longer wavelength sound waves. Let's hear it one more time. It's a super fun instrument to play at home. Really, really easy stuff. Only 2 materials that you'd have to use to create this pan flute at home. So we've talked a little bit about frequency, and we said the other property of sound is amplitude. And amplitude does not correspond to pitch. So having a high or low amplitude does not change the pitch of the sound, but it does change the volume. So the volume of a sound wave is determined by the amplitude, which we might also call the energy of this sound wave. So we've got two sound waves here. Again, they are traveling the same distance. They are traveling at the same frequency, and we can tell that because all of our peaks line up with each other, our crests and our troughs, as we might call them, they all line up. So the frequency or the pitch of these sounds is the same, but what you'll notice is the height, which we also call the amplitude, is different. On top, we have a low volume or a quiet sound. On the bottom, we have a high volume or a very loud sound because it has lots and lots of energy. This is determined just by the amount of energy that you actually put into that sound wave. It's really easy to do. Let's play one more round of our repeat after me game. The first time, we're going to repeat after me and say, "We love science," but in our quietest voice. Ready? Repeat after me. We love science. We love science. Now, maybe you didn't hear me say anything at all because I put such little energy into the sound waves coming through my vocal cords that it created a very quiet sound. But now, of course, it's one of my favorite times. I know that sometimes getting some of our energy out, especially through sound and through music, can be very, very soothing. So we'll do one more round of repeat after me. This time, we're going to say, "We love science," as loud as we possibly can. So brace yourself, brace your pets. Here we go. Repeat after me. We love science. We love science. Wow. Hopefully it didn't hurt your ears too bad. If you're wearing your headphones, I apologize. I gave you plenty of warning. We are creating low and high amplitude sound waves just with our own voices. We can change the amount of energy we put into any sound wave, right? Just by putting in more energy into the system. So if I were to tap one piece of my water xylophone, I can tap it very, very light. Let me turn my side microphone back on. I can tap it very lightly, and we can hear this sound, or I can tap it really, really hard. And the sound gets much louder. So from quiet to loud, it's all about how much energy I put into the system. But no matter how hard I tapped this glass beaker, not hard enough to break it, the pitch of the sound did not change because it's still traveling through the same amount of matter, the same amount of medium, and coming to our ears at the same pitch, but it either sounds much quieter or much louder. So very, very simple stuff and easy ways that we can manipulate sound waves at home. Now we've got two more musical instruments that we can build here today. I want to give you lots of options if you decide to start your own MySci musical instrument band at home. The first one is creating a popsicle stick harmonica, or really, it works more similarly to a popsicle stick kazoo. So what we're going to do is we're going to take some popsicle sticks or jumbo craft sticks like these ones that I have here. These are like that tongue depressor kind of size. And we are going to create basically a sound sandwich is the easiest way to describe the steps of this activity. So I'm going to go ahead, let me zoom in just a little bit. The materials you'll need for this are some jumbo craft sticks or super jumbo craft sticks, but you can also use regular size popsicle sticks if this is what you have laying around at home. We also have some rubber bands and paper clips, toothpicks, and a piece of paper. Now, you don't need all these materials, but I want to give you a couple options for how you might construct this at home. And so I picked a few different options. We'll start with the easiest method, I think, which is taking one of our craft sticks, and we're going to take one of these wider rubber bands. These are actually the rubber bands that came off some asparagus that I got at the grocery store. So they make perfect reeds for our musical instruments here. And you just take that rubber band and stretch it across your popsicle stick or tongue depressor here. This is going to act like the reed in any musical instrument. So if you know a reed instrument, or maybe you play a reeded instrument like the clarinet, this is the piece that's actually going to vibrate. Our rubber band is what's going to vibrate as we blow air through our popsicle stick kazoo. Now, the next thing we're going to add is some paper clips. And I actually just recently discovered this way of making our popsicle stick kazoo. We're going to slide one paper clip under. So I've attached it across, but it goes under the rubber band on this side, which you can see. And we're going to take the other one and make sure it goes over the rubber band. So the yellow one has gone under the rubber band. The green one has gone over the rubber band. And what that allows the rubber band to do, if we take a very close look, is it's going to allow air to travel across or through the rubber band, and it's going to vibrate with the air from your own mouth. Zoom back out just a little bit. Now, we said that this is kind of like a sandwich craft, a sound sandwich. So you take your other popsicle stick or tongue depressor, sandwich it across the top, and then you just need to secure them together with some rubber bands. So I have some tiny rubber bands here, just wrapping them back and forth. And if you don't have tiny rubber bands, of course, you don't need them. You can use regular size rubber bands. You'll just have to wrap them around a few more times. So let's take one more up close look at our popsicle stick kazoo. You can see that it goes popsicle stick, rubber band, and then there's one paper clip on top and one paper clip on the bottom of that rubber band. And you can actually see the gaps between it when I kind of turn it towards the camera like this. Now, of course, we need to provide the vibration. So by blowing air through your kazoo, that rubber band is going to begin to vibrate back and forth very, very quickly. It's very easy to do. Just hold it up and we've created vibrations, therefore we have created sound. Now, the reason I like to use the paper clips is because they're really easy to adjust your instrument. Let me remove my rubber band on this side and put it just on the outside of my paper clip. If you slide your paper clips back and forth inside your kazoo, if you slide them either closer together or further apart, that is your way to adjust the pitch of your instrument. So now I've scooted them much closer together than they were before, much closer together. And let's take a look, let's take a listen to the sound. Ready? So the pitch or the frequency of the vibration that we create changes based on where you slide your paper clips across your popsicle stick kazoo here. Now, there are other ways to make this. We said that you can also do this using strips of paper for your reed. So I'm going to zoom back down on the table. And if you don't have those thick rubber bands, you can instead create your reed out of a strip of paper. So we're going to go ahead and we'll just set our toothpicks this time, one on top of our craft stick, then our reed, which is the piece of paper in this case, instead of the rubber band, and then on top of the paper. So under and over the paper, set everything down together, pick it up like a popsicle stick sandwich, and secure it together with rubber bands. That one broke, get a new one. These rubber bands might be a little too big even. I lost, there it is. So we have one that's under, one that's over, and wrap it all together with our rubber bands and provide the energy by blowing air through your instrument. So you can really customize these kazoos any way you want. You can use tongue depressors or popsicle sticks. You could even try cutting up pieces of cardboard to act as your kind of rigid outer structure if you don't have tongue depressors or popsicle sticks at home. You can experiment using different kinds of materials as the reed for inside your instrument. Rubber bands and paper work fantastic, but changing your materials, right, will change the pitch of the sound your kazoo creates. And of course, we know that the volume, right, is provided by us. So by how much energy or air you blow across your reed, that changes the pitch. All right, I have one last sound experiment or musical instrument that you can make at home. But I did see a good question come in the chat from our friend Connor on YouTube. Asked, what happens if you yell too loud? Will something bad happen to you? And the answer is not really. I hope that no one's ever told you that. Of course, our voices can get tired, right? We know that the more we talk and the more we use our vocal cords, they can start to get strained, but that takes many times of overusing your voice. Just yelling really loud one time has no effect on your vocal cords. So if you need to let out a little bit of stress or energy, go outside, let it rip, scream as loud as you want, but be respectful, of course, of the others around you. So even though it might not hurt you by screaming really loud, it could bother other people or hurt their ears if they're sensitive to loud noises. So make sure you're aware of your surroundings, but screaming is a great way. Studies show that it can release a lot of stress. It starts to engage parts of your brain that really are related to calming you down or getting you energized. So it's really, if you feel good about screaming, make sure you do it. I know that I do it sometimes. You can also dampen that sound rate. I know lots of us have been told, you know, maybe you need to scream in a pillow. You can do that as well. But I think there's nothing better than just going outside, yelling into the sky, and just getting out some of that energy when you need to. All right. Now we've got one last instrument to show you, like I said, and this one uses a plastic cup, a string, and a paper clip. Now, the string is going to act as our reed in this experiment. This is actually what is going to vibrate, and we're actually not going to play this one with our mouth. This one we're going to play with our fingers. So you'll just need to first take your string and tie it to your paper clip. So you can kind of thread your string through your paper clip here, tie it in a knot, and just make sure it's not going to slip off your paper clip. All right, perfect. So we just tied it in a very easy knot, just making sure that our paper clip is tied to the string. Now, this one works best if your string is a little bit wet because it allows for a better vibration and more friction to take place between your fingers and the string. So I've got a little cup here full of water. I'm just going to dip my fingers down inside, and then I'm just going to wet my string. And then all you need to do is just pull. And I'm guessing you really can't hear much. I can certainly hear a sound being created by this string, but it's pretty quiet, right? We can increase the amplitude of this sound wave by giving this a sounding board, giving this a larger medium to travel through. So again, the pitch, not necessarily affected, but the amplitude of the sound wave will increase if we give this a larger object to vibrate. This string is very thin, and so there's just not much matter here that we're vibrating when we yank on the string. The cup is going to act as our sounding board. So before the program, I just very carefully poked a hole in the top of this cup using my scissors. If you're going to do this at home, of course, have an adult help you poke a hole in the top. You can use a knife or maybe even a sharp pen. But again, since those objects are sharp, my side disclaimer, safety first, always have an adult help you if you are using scissors or a knife in order to help you poke a hole in the top of this cup. That's just going to allow us to take our paper clip and poke it through the top of our, or the bottom of our cup, through that hole we created. Pull it all the way through. All right, and then secure it. So once we pull down on our string, now our string isn't going to go anywhere. It's been secured into place by that paper clip. And we're just going to do the same thing. And let me know, do you hear a louder noise this time when I play our cup? I hear a much louder noise, and I'm hoping you do too. Now, we call this instrument something kind of funny, and it's named after the sound that it makes. Can anyone tell me what sound or what animal does this sound like? Anyone have a guess what we might call this instrument? Named after an animal. You can also use this as almost a bird call, if that's another helpful hint for you. What animal does this sound like? That's right, it is a chicken cup because it sounds almost like the bok, 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 bok of a chicken. Now, all of these instruments that we've created today rely on vibrations. And so these work the same way that a musical instrument you might classically play or have bought from the store. They all rely on vibrations to make different types of sound waves. Now, Does anyone have any final questions before I bring in some very special guests into the program today? Now, we've got some very special guests who have brought their own made-at-home musical instruments. They're going to join us here on Echo Live so we can have a brief jam session using some of our fun musical instruments that we've created here today. If you don't have any questions, if you have something nearby that you can use to produce sound, you can join in with the MySci Jam Band too. So no questions coming in just yet, but we're not done yet. We are going to introduce a few other MySci staff members. We've got our rock star scientist, you know him, you love him. Raul is here to play his very own at-home paper trumpet. All right, Raul, let's see. How does the paper trumpet sound? Want to give us a demo?
Yeah, so it's a lot like your chicken squawker. So I'm going to go ahead and make some vibrations. We're going to travel down here.
Wow. All right, up next, we have our pots and pan percussion provided by Paulette, our staff astronomer and solar system ambassador. Paulette, give us a demo. Show us what you got.
All right.
Oh, yeah. All right, next up, we've got Miss Julie and Tristan playing their very own unique at-home instrument, which they're calling the Mason Jar Drums. Show us what you got. Very nice, very nice. Again, all these musical instruments rely on vibrations, including the most unique instrument I think we're going to see ever in the history of Echo Live and maybe even the history of the world. We've got Shannon playing the Spam-Jo. Look at that. So we've all brought our own at-home musical instruments. Perhaps you have one of your own. But our last thing we're going to do today is we are going to jam out as a group to a song from Detroit's very own Aretha Franklin. It is a very fitting song for the times. This song is all about respect. If you know it, sing along with us, jam along with us. If you don't know it, I'm so glad you're hearing it here on Echo Live for the very first time. But we are going to go ahead. We're going to jam out to Aretha Franklin's Respect, and we will see you back here tomorrow. Let's go, guys. Let's see if it plays. Thanks everybody so much for joining us on Echo Live today. We had a great
he's
time
my miracle
this
child.
program. We hope we'll see you back here tomorrow for another episode of Echo Live, where we're going to talk all about nuclear reactions. Thanks for sticking around. Thanks for tuning into Echo Live. If you are looking for some activity guides of how you can create any of these activities at home, go ahead, visit the Michigan Science Center's website as always, and we hope you have a great rest of your day. Goodbye, everyone, from all of us here in the My Sci Jam Band. Thanks, everyone, for